this video, we will make the composition of line following robot, ultrasonic sensor robot, and we store the values in the SD card module. So following is the code. We have initialized the pins first. The SD pin is connected to pin 10, the CS pin of SD card. Then there is motor driver pins. The motor drivers pin E and A is connected to 5, LM1, in which means in 1 is connected to 6, in 2 is connected to 7, in 3 is connected to 8, and in 4 is connected to 9. The E and B of motor 2 is connected with the 4 of pin. Then we have connected the servo motor on which the ultrasonic sensor is mounted. The servo is connected with the pin 3, and we have declared the variable name for servo as my servo. Then we have defined the left, center, and right values of server. As the server rotates 180 degree, we have to find the center of it and the total left and total right value of it. So we have initialized the center value of it at 90 degree. Then we got the ultrasonic sensor. We have 3 pins, basically 2 pins, ultrasonic sensor and one for the servo pin. This is the robot. As you can see, these 2 pins are echo and trigger pin, and pin 3 is the servo pin. The ultrasonic trigger pin is connected to A4. The ultrasonic echo pin is connected to A3. Then we have 3 sensors, which are line tracking sensors mounted here. There is one left sensor, center sensor, and right sensor. Left sensor is connected to A0, and then A1 and A2. These are the variable pins of Arduino, which we are going to study later. We have used 2 speeds in this circuit because one is for the forward and one is for the backward. Then we have initialized the threshold at which the ultrasonic sensor will will see a hurdle, and when it will detect a hurdle, it will send a signal to servo motor, and the servo will rotate left and right and will see which on which way there is no obstacle. Following is the scan interval. This is set to 300. These are the flags which we have used. They are false. It will be detected in the code further. Next, we go to the setup. For the serial communication, we have used serial.begin. The servo is attached. As you can see, here is my servo variable name, and attach means servo pin, which is servo pin is 3. Servo center is 90, and it will write it in this variable. Delay will be 500 milliseconds. Then there is motor pins. We have used these names for the motor in 1, in 2, in A, in 3, in 4, and in B. These all are outputs, as motor do not give us input. Next, the sensors will always give us input, so there will be declared as input left, center, and right. Then the ultrasonic pins, these are also inputs. Instead, one is input and one is output, because it will send a wave and will receive a wave. So the sending of wave is output and the receiving of wave is input. The sending is triggered and the receiving is echo, input and output. Then there comes the SD card. For the communication of SD card, we have used serial print. It will print the this thing onto the screen. The screen which we have connected is at pin 2. As you can see here, the RxD of screen is connected with the TXD of Arduino, because that is the trigger and that is the receiver of screen. It is a trigger of Arduino, so it will trigger this pin for the serial communication, and this screen will observe the triggered value at the receiving side. Then comes the following analog write. We have used the ENA speed and we have used ENB speed, and here comes the loop, the main loop of the circuit. First of all, we have used the servo motor. It will first check the distance in every loop, whether there is an obstacle in front or not. Distance will be get distance, and we have used this function. We will use this function later in the program. It will see if the distance is greater than 0 and distance is less than or equal to obstacle threshold, which is 8 in our case, it will freeze the robot. And in this if condition, when it will be frozen, then comes this condition: if object not locked, which means object is present, it will store the value of this, which is the roll number and id, into the variable msg, and msg is our string. Serial print, it will print object detected onto the screen. Serial print, it will object print the this value, which is msg, this my roll number and name into the msg. It will be printed and shown onto the screen. This thing we have used to log the sd card into the file, which is our log file log. If the object is logged successfully, which means it is true, the server will pause and it will the loop is terminated. The next thing, which is the most important thing, is the line tracking. We have used the digital read for left values, center values, and right values. The IR left will get written at this value, left value, and it will store the value of this into this, which is an integer value. The IR we have connected, as I said earlier, these are all connected with the analog pins. Here we have used these analog pins to store this value. We can either take digital or analog for both of these values, because we are reading it in analog form. The ultrasonic sensor, we have taken its threshold to 300, so we have connected it to analog too. These are the conditions which we have used. Let me explain it step by step. If the left value, as the thing is to remember that left, center, and right, these three values will taken from the three sensors, and then we have used the conditions in it. If the left value is high and at the same time the center value is low, it will turn left. Simple. And the above condition was, if the center value is high, it will always move forward. Next condition, if right value is high and center value is low, it will move right. If left value is high and right value is high, it will move forward. If the center value is high and right value is high, it will turn right in this case too. If the center value is high and left value is high too at the same time, it will turn left. And in the remaining conditions, it will move forward. We have not stopped the robot in this. Next, the servo scan, the servo pause conditions function, which we have used earlier, because when the object is detected, the servo will scan the object, the environment for any hurdles, more or not. My servo dot right, servo left, we have taken 45, and scan interval we have taken 300, I guess. And d left is, it will use the get distance. We will see the get distance function later in the program. First it will move to the left, then it will move to the right, and then it will move at the center, which is its base location, 90°. At the same time, it will print these things in the terminal. These things will get printed on terminal with each line. And if t, and these things are we have used for the servo, it will turn left, either it will turn right, or it will get frozen at one place. We have used this condition to stop the robot at a specific location. Next, these function will write the details in the SD card module, and it will save the file with this name, which is log.txt. It will store in the txt format. And when it will write this thing successfully, it will show us a message, write sd card successful. And if it's not the case, sd write failed, because we have unable to find the specific file which we are going to write. There comes the ultrasonic thing. We told him that we have connected a trigger pin and the echo pin of ultrasonic to analogs. First, this is the function get distance function, which we have used earlier. Now it is the definition of it, the function definition. First, it will write the trigger pin. It will low the trigger pin for 2 microseconds, and then it will high the trigger pin for 10 microseconds. Then the trigger pin will also get low at the same time. Trigger pin will send the signal, and this signal will get read by the echo pin. The echo pin will read it as a pulse, and it will be high. When the echo pin will be high, it will receive the trigger pin. Next, it will return the 999 value, which is its maximum. Duration will be 0. If the duration will be 0, the return will be 99, which means there is an error in this condition. Next, that is a formula to find the distance in centimeters. It is 0.034, which is the speed of sound divided by 2. That's the formula basically to convert the receiving signal into centimeters. The functions which we have used earlier to move forward, right, left, and to move backward are as follows. We have used two speeds for ENA and ENB. We can use these speeds, adjust these speeds in the start of the program. The correct orientation of in1, in2, in3, and in4, which is LM1, LM2, RM1, and RM2, is this. When it is low, the other one is high, it will move in the forward direction. When this one is high and the other one is low, it will move in forward directions. That is the connections which we have used in the program. At the same time, it will print this thing onto the terminal that it is moving forward, left, right, or stopped. Then comes the turn left. It will move this motor in the opposite direction, and it will move this motor in the forward direction. And with the motor which will get moved in the opposite direction, we have used this low speed for it, and it will show the direction left. We have used this thing and inverse this logic and use it in the turn right signal. And lastly, we have used this to freeze the object. We have turned off the 4 motors, and we have used the A, B to 0. These are not necessary, but just for the safe side we have used this. It will show this signal onto the screen, and just in case if we ever needed back signal, we have inverted both of these calibrations to high low and low high, so the motors will rotate in the opposite direction. So let's run this program into this circuit. And by the way, we have used the clock signal of SD card and connected it with the clock signal, and we have used this master in slave out signal and connected it to DO, which is output, and the I, which is master out slave input, and the CES value is this. We have used OC1 for this. This motor is connected with pin 4, pin 9, and pin 8. Pin 4 is basically the ENB pin, and pin 8 and 9 is basically IN3 and IN4. These 3 pins are connected exactly like this with 7, 6, and 5 pins respectively. Pin 4 is connected with this ENB. Pin 3 is connected with this, which is servo pin, and we do not use this pin. A0, A1, and A2 is connected with the left, center, and right sensors. A3 and A4 is the basically trigger pin and echo pin of ultrasonic sensor. And let's run this program and see the results. As you can see, it is first detecting and at the same time showing forward in a direction. When only one sensor will detect the signal, it will move in this direction. At the same time, the ultrasonic sensor is set to 90°, which is center of it. It is continuously detecting, and when it will reach the threshold of 8 centimeter, it will stop at this direction. Right now it is not 8 centimeter, it is moving right forward, as you can see here. And here comes the obstacle. It is scanning left and then it is scanning right, and it is still processing it. As the obstacle was present in it, it will not move, and when I take it and drop it here, it will start moving again. So that is the working of it. When we stop it, and we will open the log file of it, you can see there is a log file present here. Let me copy it here and replace the existing one. It will show this signal as I ran it earlier 2 times, and the following time this location, this thing will get printed onto this log file. So that is the log file of it. So that's it. We have used, let me summarize it for you. We have used SD card module. We have used the turtle robot, which is the by default blindfolding and obstacle avoider robot with the sensor pins. We have used the serial receiving of screen to get the triggered value, which is serial print ln, we can use in the program. We have used the ultrasonic sensors and connected it to A3 and A4. We have used the line following sensors and connected it to A0, A1 and A2. And we have used this program, uploaded into the Proteus, uploaded it. No, we have not used this program. We have uploaded the SD card file, which is sd.ima, which we just opened earlier, and we've seen the log file into this. We have used the map which we used. We have to upload it into this obstacle map, and that's it for the line following robot.